So just a quick recap of what we have done so far in this unit. So we have started with unit 3 with the network layer, and we discussed briefly about the different functions of network layer. It is the network layer which is the layer between the data link layer and the transport layer, and this network layer is responsible for inter-networking. It means it is responsible for efficient transfer of packet safely from the source to the destination point. It means it has to combine different small networks to make it an internet, and that internet working is done by the network layer. Secondly, it's a responsibility of the network layer to define or to allocate address to each and every device associated with the network. Then it is also responsible for packetization, fragmentation, multicasting, routing, everything is taken care by the network layer with the aid of different protocols. And we have the different devices in the network layer, which we have already seen. We have discussed about the hubs, passive hubs, repeaters, switches, bridges, routers, gateway, which are all the different, not only for network layer, but also some of the devices are meant for even the layer above the network layer, the gateway. What I mean is gateway. We have also started with the routing algorithm. Distance vector routing is already discussed, half, and we are left with the link state routing and example of distance vector routing, which will be dealt in the offline class, probably I think on Thursday and Saturday. We will be completing that. And today we are going to discuss addressing and subnetting concept. Probably tomorrow the different protocols will be discussed. So we'll try to complete, or we'll try to wind up this unit in this week, if possible. So now moving on to addressing. What actually, when I say address is actually called by different names or by different terms when it comes to the different layers. So we have here the TCP IP model, in which we have the 5 different layers. So each the message what I'm going to convey, say we call the packet name as a message in case of application, and when it goes into the transport layer, like say for example, if I want to send a mail, how do you send the mail? You just give it as your mail, your name, something, says Ravi at the rate of gmail.com. So that is the address that is meant for the application layer. Whereas in the transport layer, it will be segmented. I mean, you call it, we allocate port numbers so that the sender is identified uniquely. Then comes the network layer, in which the network layer will allocate logical address, and we call that corresponding packet as a datagram in the network layer. And then there is going to be some more add-ons, which we call it as MAC address. So you've already seen that is for the data link layer, where the packet name is given as a frame, where you will have a header as well as a trailer, in which you will add some more extra features so as to detect as well as correct error. And there is no name given to the address for the packet, because in the physical layer we don't actually convey it with respect to any address, because the data that is transferred there includes only bits. So actually communication in the network layer is said to be a host to host, means that from sending end to the receiving end, and it is the work of this network layer to transfer the packets safely across different LANs or even WANs in order to reach the destination. So for doing this, it needs some kind of addressing, and we call that addressing scheme, which is available in the network layer, as logical address. And we are going to use some protocols, and as such this network layer is going to be using the protocols which actually and the addressing is said to be called as IP address, which is nothing but the logical address that is used in the network layer. I'm talking about the TCP IP protocol, I mean model. So what is actually the IP address? IP address stands for internet address. It is said to be the identifier that is used in the internet IP layer, that is in the network layer. So the work of this address is to identify each and every device that is available in the internet. So there are 2 different versions of the IP. that is Internet Protocol. First one is the version 4. The version 4 actually uses Internet IP address, which is of length 32 bits. So when I say 32 bits, almost we can have 2 power 32 combinations. So when it has a 2 power 32 combination, you know, it's going to be generating this many addresses. So at the time, it is capable of giving 2 power 32 different address to the device connected in the internet. So that is the IP version, in IP version 4 addressing IP address. Now, if as this was the earlier one, which as such now is said to be obsolete, and in order to give the need of more addressing, or as we know in the internet, if day by day, if more and more devices are getting added, so that give rise to actually a new, an improved version of IP, which we call it as the IP version 6. This IP version 6 uses 128-bit addressing. So when I say 128-bit size to represent a particular address, then you can have 2 power 128 combinations, or as such, I can generate 2 power 128 different addresses using the IPv6. Okay, so we'll move on. So let us now discuss about the IPv address. So this IPv address is of size 32-bit, and each and every device is said to have a unique address. Like how you are, how do you be identify in the university? We identify each and every one of you uniquely by your register number. No two students can have the same register number, right? So likewise, here also in IP, Internet Protocol version 6 is going to make use of a 32-bit size length address, and that address is said to be a unique one, unique to each and every device connected in the internet. Okay, so, and it is also said to be universal. Okay, so, and each and every I can say this protocol, like this IP version 6 is going to consider, or if I say the total size of the bits used to represent the address is n, then the total address that can be generated is said to be 2 power n, as you know, and this entire size or the entire content of 2 power n different address, you call it as the address space. So when I find the value of 2 power 32, you can read. So 4 billion, so 1, 2, 3, it goes how much? 42,949 lakhs 67,292. In whichever format you want to read, you can read it. So this is the size of the address that can be generated if IP version 6 with the 32 bit address is used. Okay. So as such, if there is no restriction at all, then we can able to have 4 billion devices which you can able to uniquely identify by the address. Now, when you look into the notations, how actually this address is, IP address is identified, or out, what is the notation used? There are two different notation. One is the binary, second one is the dotted decimal notation. I think you are all familiar with the different number representations, isn't it? As I think you're all familiar with it. Are you all familiar with the different number systems?
Yes.
Yes, ma'am.
Okay. So if I use binary notation, then you call it as the binary is used. If all 32 bits are represented in binary, then that is the binary notation. The equivalent of binary, every 8-bit of binary. So 32 can be considered as, so what is the name given to combination of 8-bit? 1 byte. So if I group all 32 bit as groups of 8 bits each or 1 byte, then you will have 4 bytes, isn't it? So each of this byte, if I represent in decimal, then if I separate them by using a decimal point, each byte when it is separated by using a decimal point, then you call that as the dotted decimal notation. So an example is given here, so you can able to see. 0 0 0 1 1 1 0 1 0 1 is one byte. This is second byte, this is third byte, and this is fourth byte. Each of them, when you convert each byte into its equivalent binary, you will be getting it as, so this is for 2. And what is this? 0 0 0 0 1 1 1 0 1. So this combination, if you add, if this is converted into decimal, then it is equivalent to decimal 29. How do you get? You want me to tell you just this example? So here I can write this as 1 into 2 power 0 plus 0 into 2 power 1 plus 1 into 2 power 2 plus 1 into 2 power 3 plus 1 into 2 power 4. And all other things, as you go further for higher powers of 2, it was all 0. I'm not writing that. So this is 2 power 5 into 0, 0 into 2 power 6, 0 into 2 power 7. If you add anything to the power of 0 is 1. So this is 1. And then we have the next bit multiplied by 0, anything multiplied by 0, 0. So here 2 2s are 4. Then 2 power 3 is 8 and 2 power 4 is 16. Just add them. 16, 20, 28, 29. Yes, are you getting? Now this next byte corresponds to 149 and the next byte corresponds to 117. So this is the dotted decimal notation, and for the equivalent binary notation to represent the address in the logical address. So this example, another example is given here. How do you convert another binary format into the this dotted decimal notation? As you see, you can able to see all 32 bit are combined into groups of 8 bits or 1 byte, and each of this byte is converted into its an equivalent decimal, and they are separated by a dot. That is said to be IPV. Another some more examples.
Ma'am, 1 second, previous slide.
Okay.
1 minute.
Yeah, just if you look into the second, I'm not going, okay, if you look into this, how do you get it as 128? This is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. All other things are 0, so 1 into 2 power 7. So what is 2 power 7? 2 2s are 4, 8, 16, 32, 64, 128. Yes, do you get this? And how do you get this? 1011. Here is 8, 9, 10, 11. And here 1, 1 is 3. All 5 ones, 2, 4, 8, 16 plus 1. Everything added gives you 31. Is this clear? Any doubt? Any doubt you have? Shall I proceed?
Yes, ma'am. Proceed.
So moving on to the next slide. So another example of the dotted decimal to binary as well as binary to dotted decimal conversion. So here 1, 1, 1. So all these things we have already seen. So I'm not repeating. Decimal to dotted decimal. Here if you see, if you look into this IP address from dotted decimal to binary, you can able to see 1, 1, 1. How do you get this as 1 from 1, 1, 1? How do you get this 8-bit number? You have to go in for the long, what do you call this? Go keep on dividing it by 2. So 55, you get it as 1 remainder. Then again you should do division 20, 7, 1 remainder. Again 2 times 1, 13, 1 remainder. Going on further, you get it as, I'm doing just division, and if there is any remainder, I'm just adding that. If there is no remainder, I should put it as, so how many times 6 goes into 2? 3 times. As there is no remainder, I'm just writing it as 0. And again, if I go and divide 3 still by 2, it is 1 time and the remainder is 1. So as this number is lesser than 2, I'm stopping, and you have to read from bottom to top. So 1 1 0 1 1 1 1. See, 1 1 0 1 1 1 1. As you have to make it into 8 bits or 1 byte, I'm prefixing the 7th or 8th bit question, the MSB question, as 0. So this is the equivalent of the decimal number 111. Likewise, if you do, you will be getting for 56, this is the equivalent, 45 as this, and for 78, you will be getting this binary as the equivalent. So this is the binary equivalent. I hope it is clear to all of you. Is this clear? We'll move on.
Yes, yes, ma'am.
We'll move further now. So now, how actually is addressing taking place? There is going to be some hierarchy that is going to be followed here. So actually, if I just have to, send a post, okay, just to imagine you want to send to your friend, you just have to send a post. What will you write in the address field of your postcard? What all you will be writing? You will write the person name. Then what you will write? You will write the street name. Then what you will write? You will write the door number, street name. Then you will write the corresponding area, and
Address,
then you will mention the
address,
district. When I talk about address, it's not just one single line. You will be going, you'll be following some hierarchy. What is that hierarchy? It means you will specify the name to whom you want to send the post. Then you will specify the door number. Then you will specify the street name. Then you will specify the maybe some
pin code also, ma'am.
yeah, finally, yes. You will specify the the city or
City,
state. Then you will mention the country. Then if
country,
possible, if you will also specify the pin code. So this is actually said to be called as hierarchy. Do you understand what I'm saying? Likewise, in communication network also, when a packet has to be delivered, then it is going to be, the addressing system is going to be following some kind of hierarchy. Okay, so this IPv6 address is, which is a 32-bit address, is also said to be following some hierarchy. It is meant having two level of hierarchy. It means the first part of the address, you always call it as the prefix. It is going to be used to define the network part. It means when I talk about network, the network, what is actually network? Interconnection of different devices, isn't it? So that is said to be a network. LAN can be a network, WAN can be a network. So the first part of the address, which is called as the prefix, which is the first part, is going to define the network, to which network it is, this corresponding address is going to be, it's going to belong. Then the second is said to be called as the suffix part. So prefix is also called as net ID, suffix is called as host ID. It is going to be used to illustrate or to define the device that is connected available in the network. So as I told you, the network will be made of different, I can say, I can correlate this to maybe to the city you belong, could be the prefix, and your street, your door number could be the suffix. Understand what I'm saying? Do you understand? So when I talk about addressing, addressing is going to be hierarchical in nature, and your IPv6 address is also said to be hierarchical, which is having two level of hierarchy. The first part of the address is used to specify the network, the that it is going to be used to illustrate which network. Say I'm just taking the example of our postal system. In our country, we have different places. means we have different cities, towns. So when I specify in the address the name of the town or the city, then that defines the network. And it in a city there will be we are so many, right? How to identify you, particularly you, by your door number and your street number. So that is illustrated in the suffix part. Okay. So the prefix could be fixed in length or it could be variable in length. Depending on this nature, you can classify your addressing as classful addressing and the classless addressing. Okay, so if I have a fixed length prefix scheme, then it is said to be called as classful addressing. If there is going to be a variable length for this network prefix, then it is said to be the classless addressing. What is this classful addressing all about? So in the classful addressing scheme, we are going to divide the entire address space. That is, as I told you, when there is 32 bits available to represent address, then we can have 2 power 32 combinations, or at most you can have 2 power 32 devices which could be addressed. And as this entire content of address is said to be the address space, and it's not going to be one single long length address space, but it is divided under 5 different classes. So as the address space is divided into 5 different, or based on classes, we are going to define the addressing scheme. We call it as the classful addressing. So in classful addressing, there is going to be 5 classes. Just a second. So we are going to have 5 classes. They are called as class A, class B, C, D, and E. Okay. So each class is said to be occupying a certain part of the address space based on how many size is going to be the prefix and the suffix. We can go in for the further subdivision. So in classless addressing, this addressing mechanism where we are not going to divide the address space into classes, and the prefix is said to be variable in nature. So now you can able to see the different classful addressing scheme, which is meant for when represented in binary as well as in dotted decimal. So in place of class A, we are going to use the first byte to represent, or the first byte illustrates the prefix, and the second byte is going to be used. Just a second. See, you can able to see how actually in classful addressing, how the entire address space. So when I say talk about address space, it includes all 2 power 32 combinations of addresses. So, and in classful addressing, they are going to be divided under different classes, and the weightage or the occupation of each of the class is illustrated here. Class A occupies 50% of the address space, whereas class B occupies 25%, and as you go further, the occupation of each of the class keeps on decreasing. And in class A, the prefix is said to be of 8-bit, whereas the suffix is going to have all rest of the bits, which is 24 bits. Whereas in class B, the prefix is made of 16 bits, and the suffix is going to occupy size of 16 bits. And class C, prefix is made of 24 bits and suffix 1 byte. Class D is not meant for the first 3 are meant for unicast address, whereas the second class D addressing is meant for multicasting, and class E is actually reserved for future use. Now, moving it back, you can able to see. So from the representation of the number, you can able to identify from the address, you can able to identify the class. Okay. So always class A address will start with a 0. When I have the 0 available in the second bit of the first byte, then it is class B. When the 0 occupies as the third bit from the MSB, then it is class C. And when the first three bits are 1 and the fourth bit is 0, then it is said to be class D. When all four are 1 in the first byte, when all four bits from the MSB is said to be 1, then it is an indication that the address is for class E. Okay. And if the same thing is represented in dotted decimal notation, we can able to see any, if there is any number with 0 to 127 in as the first byte, then it is the class A. Whereas when the equivalent decimal is going to range from 1128 to 19,111, then it is class B. Can you able to see, or can you able to see, say why I'm saying this? Can you able to interpret? See, class A always has an MSB as, sorry, class A always has an MSB as 0, which means when I talk about 1 byte, it means it has 8 bits. So 1, 2, 3, 4, 5, 6, 7, 8. So this is 0. Only then it is class A, which means the other 7 bits of 1 byte could be any number. The minimum is all zeros. The maximum is all ones. So only I write, this is the binary equivalent. If I convert this binary into decimal, then it is all 0 means 0. If you convert this binary combination as into decimal, you will be getting it as 127. That is why in decimal notation, whenever we have the first byte as the number ranging from 0 to 127, then we call it as the class A. Likewise, if you go further, when I have the first two bits as 1, 0, then you can able to have, so here the length is 2 byte. It means one more 8 bit goes. So it could be 1, 2, 3, 4, 5, 6, 7, 8. I hope you all can able to understand what I'm trying to write, or what I'm trying to say. Do you understand? So this is for class B address. So here the first bit is supposed to be for class B. What is the first bit supposed to be? What is the first bit supposed to be for class B addressing? 1, 0. So it could be any number ranging from 1, 0 to all zeros to 1, 0 with all ones. If you convert this into the equivalent decimal, you will be getting the number as 1128 to 19111. So if your number is going to be, when it is illustrated in the dotted decimal notation, you can able to identify the particular class in classful addressing. So moving further. So just if you look into, so you can able to identify the class of each of the address given. So here the first, if you, when the interpretation is given in binary, just you have to look into the first bit, that is MSB. If this is 0, then it is class A. And second category, first bit is 1, second bit MSB is 1, next to MSB is 1, whereas the bit next to MSB, I mean the third bit from MSB is 0. So when the third bit is 0, what is the class? It is class C, because we know that is how class is illustrated. Likewise, when I have the first decimal notation as 14, then it falls into class A. And here 252, where it comes 252, it goes into, see, 128 to, so 252, it goes into 240 to 255, it corresponds to class E. It corresponds to class E. Why? Because in class E, all 4 bits are 1. So it could be all numbers ranging from 0, 0, 0, 0 to 1, 1, 1, 1. So when I talk about the first byte, it could be 4 zeros, 1, 1, 1, 1 with all 4 ones. So that is the range of the class E addressing. Hope you can able to understand. So from the addressing, you can able to understand in which class the particular address belongs to. Okay. Okay. See, here. If you look into the class E, when I say class E, it is when you look into the first byte for class E addressing, it is supposed to be all first four bits has to be 1. There is no change because it is class E. Whereas the next four bits of the byte is going to range from all zeros to all 1. So what is the equivalent of 1, 1, 1, 1? So 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4 plus 2 power 5 plus 2 power 6 plus 2 power 7. So what is the answer? 2 2s are 4, 8, 16 plus 32 plus 64 plus 128. Just add all of them together. What is the number you are going to get? And then if I convert this all ones into the equivalent in into decimal, what you will be getting? 16. So 128. What you will get? Can you say? Just add and tell me. What you will be getting, ma? So 16 plus 32 plus 64 plus 128. What you will be getting?
160 to 255.
All ones if you make, what you will get?
Ma'am, lower bound will be 160 to 255. It will range
160,
60
yeah.
255.
255. So if you look into the, so it now this is the range of the first byte if it belongs to class E. Now I'm moving to the next slide. So 252 as it falls, if you convert this, if you make this 252, 252 is a number that belongs to class E. If you same way, if you go for class D or class C, it will not be in this range. So I can able to make out from the first decimal notation, first byte of the decimal notation, it belongs to class E. Do you understand? Is it clear?
Yes, ma'am.
Okay. So moving further. So in classful addressing, there is going to be, as I told you, prefix and suffix. So that part which is going to be used to identify the particular network is the prefix, and suffix is going to be used to identify the particular device host in that particular network. Okay. So in class A, only 1 byte is meant for the net ID, that is the prefix, whereas 3 bytes are meant for the suffix. The meaning is, actually what actually when the this IP address was actually formed, it was only meant with the class, with the classes, and they thought that there is class A, actually class A addressing was meant to meant for larger organizations, which means if there is one single organization, and if that organization has lot of, just a second, ma'am. Yes, ma'am, sorry. So in class A addressing, actually, when this IP addressing was formed, they thought that class A addressing is said to be suitable. They thought of dividing the addressing into different classes with the motive that class A address could be meant for larger organization, and class B could be for mid-size, and class C is for smaller organization. The reason is, if you go back and if you look again into the prefix, what did I tell you? What is the use of this prefix? What is the size? Just a second. I'm just closing all other windows. What is the use of this prefix, ma? Can you tell me? This prefix is meant for identifying the city. Just an example. So it has 2 power 8 combinations. What is 2 power 8? What is the value of 2 power 8? What is the value of 256? Which means at most around the world, if class A is used, only 256 organizations can make use of them. But each of this any one of the organization can have 2 power, what is 256, 2 power 32 minus 8, 2 power 24, right? 2 power 24 different devices for that particular network could be addressed. So that is the meaning of class A addressing. Do you understand what I'm saying? You just imagine, even for our country, we have more than 256 cities, isn't it? So even for one single country, if it is not going to be sufficient to identify the each of the city by combination, by only having 256, how that will be suitable for the entire world? That is the main problem. And on the other side, as the suffix is of 2 power 24, is of very long length, isn't it? So that this very long length 2 power 24 for one particular organization, it is very much higher, which means most of the address is said to be based. Likewise, even for the mid-size organization, they found it's not suitable. And when it comes to the class C, what the actually the inverse of class A actually happened here. They allocated 24 bits for identifying the network, whereas only 8 bits are meant for identifying the host in the network. And again, that is not sufficient. Even very small organization, they could not this only 8-bit size to address the host in the network is not found to be sufficient. So these are the problems that is associated with the classful addressing. So this is the flaw, and that is said to be called as address depletion. It means a block in class A is said to be too large for any organization, which means a lot of address when they choose class A is said to be waste. Whereas class B, when they found that even for any organization that received the class B addressing, they also found it to be very large. Again, when it comes to class C addressing, they found that it is even that is not suitable for many organizations, even though this type of class is said to be suitable as it could accommodate more addressing for the network. The size of the suffix is said to be too small for many organizations. And that is and again, when it goes to class B, it is mainly meant for multicasting. What is meant by multicasting? Whenever there is said to be more than one receiver, then it follows that process of transfer of packet is said to be multicasting. So that is again is not going to be suitable. And again, what happened finally with the class C is actually reserved for future use. So again, as it is not free, it is said to be reserved. They are also going to be a lot of waste in the addressing. So altogether, we found that the classful addressing resulted in address depletion, and this is the flaw with this method. So they try to avoid or they try to remove or rectify this by the strategy called as subnetting and supernetting. Actually, in subnetting, what they did was with the class A or class B block, when they even with the class A, actually there are two ways to solve this problem. If there is a possibility to increase the size of bits to represent the address, that is the next version, IP version 6. But as such, it could not be made immediately. It could not be implemented for the entire world all at the same time. So they try to make use of IPv4 itself, and they actually try to use some strategy, and that strategy is said to be called here as subnetting and supernetting. So what actually they did with subnetting is, if they even if you take class A or class B, it's the entire network is not going to be taken as such. It is internally subdivided into smaller units, and each is said to be called as a subnet. Okay, so when I take class A, the class A network is going to be divided into smaller subnets, so that we can able to allocate that subnet to the even though the large organization, even though if all the address is not meant for the large organization, some 2 or 3 organizations can be combined together and they can be allocated with this scheme. But what happened was, none of the organizations are not, they were not happy because they don't want to give their unused address to smaller organizations. So that is the main problem. So they thought of using the concept called as just go to so they thought of going for this classless addressing. So what is actually this classless addressing? As I told you, most of the address is said to be wasted in the classful addressing. To eliminate this, they try to use the classless addressing. It means in this addressing scheme, uh, there is not going to be as such a particular block allocated, or there is no such a fixed size for the prefix, but the entire address space is going to be divided into smaller blocks, and each block is going to be allocated to the particular network. And this block is not actually a constant length block. They are going to be varied in length. Say, as you see here, block 1 is of some size, whereas block 2 is of a different size. And the entire address space is said to be divided into smaller blocks. Each block is of variable length. And actually this concept of variable length or classless addressing, they came into picture when actually when the network actually the network providers, internet providers, they actually they are the organization who takes care of all these things. And when they came to picture, when they try to resolve, and when they try to give address to the requested organization or provide address to the requested organization or to an individual, they thought that classless addressing will be more convenient. So only this classless addressing scheme, even for IPv version 4, is being used. So what is actually happening in the classless addressing? You can able to see in the in the uh, decimal dotted notation. So this is an address. So 167.199.170.82, and we use a slash here, slash to a number here. What is this number represent? This number actually illustrates the size of the prefix. So here, which means when I say this size 27, it implies 27 bits are used to represent the prefix, and the rest of the bits are used to represent the suffix. The larger the number, lesser will be the, when I say the lesser number, it means the network will be when I say when the prefix number is smaller, what is the interpretation? It's similar to class A in classful addressing, which means the network size will be smaller. Whereas if the prefix length of the prefix bit is said to be larger, then it is inversely related to the corresponding network size. So this is how actually in classes addressing it's going to be illustrated. So some examples. So we have the first byte, second byte, third byte, fourth byte, and there is a slash, and we have that number n. So this number n actually illustrates the length of the prefix. So these examples. So this 8, what does it 8 represent? This 8 represents the first byte, which means it's similar to class A. So here it is the first byte which is used to represent the prefix or net ID, and the next rest of the bits are used to represent the suffix or the host ID. Here it is 12. It means 12 bits are used to represent the prefix, and the rest 32 minus 12, 20 bits are used to represent the suffix or the host ID. I think it's time for the next hour. Okay. And how actually information is extracted in classless addressing? So in classless addressing, they use the concept called as masking. So they use the concept called as masking. So based on this number, this slash and number is there, no? Based on this number, a mask will be put, which means it will be doing, what is meant by masking, no? What do you mean by masking? To hide something, we will put a mask, isn't it? Likewise, here also, to identify a network, the corresponding network address, because that is very important for a router. It's because when a packet arrives at the router, then the router from the routing table has to identify the corresponding network, isn't it? Only then it can forward the packet to the network, and then it can be, if it's said to be belonging to the particular host, then it can send it to the corresponding destination. So in order to do that, it is very much required that this network ID has to be found. It's time, right? So an example is seen. We'll do this in the next class. Just look into this example. I'll complete with this slide. If you look into this example, this is an address and there is a slash, which is 27, which means first 27 bits are meant for representing the network ID, isn't it? Net ID. Whereas the 32 minus 27 is 5. And the last 5 bits are meant for representing the host ID. So it's given here. So it ranges from all the same binary equivalent of 167, 199, 170. And then the first address here, it is all 5 zeros to all 5 ones. So it is ranging from 167.199.170.64/27 to /95 /27 0.95 to /27 is the last address. So if there is a mask which is provided here, and to the first 5 bits, to the last 5 bits, then this 27 bits can be used to identify the network address. So when I talk about the masking, it involves 3 operations, not and an or operation. We'll do that in the next class. I think it's time.
Yes, ma'am.
Ma'am has joined. So
Yes, ma'am. Ma'am was done. Yes,
yes,
ma'am.
yes, ma'am. We'll continue the rest in the next class. Thank you, ma'am.
Ma'am, once again, ma'am.